we're talking about linear inequalities. We will in just a second. This here is the equation of
A line.
a line. Yes. So if we want to graph this, what will that look like?
Maybe.
Actually, hold on a second. Let me redo this. Let me put my. Oh no. Put the axes in black.
No, black's not a color. Do blue at least.
No. All right. So say we're going to do. Okay, a very rough sketch here. All right. So this line here has a y-intercept of 2 and a slope of 1/3. So right there and about there. So it looks about like this. Right?
Mm-hmm.
We've done that for a long time. Here is the graph of this line. So here's the graph of this line. Now this is a linear equation. And today we're learning about linear inequalities.
Uh-oh.
So you have to like graph the things that we already learned on.
Yeah, so we have done inequalities on a number line, right? One-dimensional graph. There's only it's just on a line. It's only one dimension. Well, now we're going to have 2 dimensions.
Yay.
So linear inequality, an inequality that involves a line, a graphed line. It's not as scary as it might seem, though.
Oh.
Let's say that instead of y equals 1/3 x plus 2, let's say the equation was y is greater than or equal to 1/3 x plus 2.
Oh.
Well, does this inequality include this line?
Yes.
Yeah, because it's I wrote y is greater than or equal to this. So what we had here is y equals this. So this part's the same. And all we're doing now is we need to do some shading. If you were to guess, where do you think we would shade?
If it's greater than 1/3.
What is it?
This.
This way?
Yes. I was.
Do I have to do it with flare?
Wait, do it again. The camera didn't get it.
No.
Aw.
Snooze, you lose. That's what pause and rewind buttons are for. Okay. What axis?
No, like you were out of the frame.
Oh, pity. What axis is this?
The X.
What
That's
axis
why you
is this?
always label it on the other side, so then when you
Yeah.
read it from left to right.
If we say that y, y is greater than or equal to this,
It's going to be that way.
and if we're on the y-axis, we're vertical, and if we are, in what direction does y get greater? Up or down?
Up.
Up.
What about this one?
That's X.
So if I want to represent this linear inequality on a graph,
Has to be on the
I
y-axis.
would draw the line, what it would be if it was equal to, and then I'm going to shade everything that is above or greater than. So I would shade this.
Oh, you're drawing it out. So beautiful.
You're drawing out magenta plumberry.
Love it.
Hey, you guys pick the color.
No, we didn't. You just chose it for us.
Yeah, that's actually true.
So that's the idea.
I can do
Now.
it on the computer.
Yes, I know, but I expect you to do it by hand. All right, but doing it on the calculator is a great way to check it.
Can you do it on these ones or not?
Can those graph?
No.
There's your answer.
Aw.
All right, now let's say that this was y is greater than instead of greater than or equal to.
Where's the line?
It would be an open circle all over that.
I'm not sure. The right concept. What do we do when we graph a number line? Let's say that I'm graphing x is greater than 2, and let's say that our domain is reals. What would I do? What would I do right here?
You put an
Open circle.
I put an open circle
and then put an arrow.
and then an arrow to the right. Why would I do an open circle? Or what's the question?
I don't really understand that, because why couldn't you just do a closed circle on 3 and then do the arrow?
That's what I've always thought.
Why wouldn't
What about 2.5?
It's greater than 2, and it's a real number.
If you did a closed circle on 3 with an arrow to the right, what about 2.5? Is 2.5 allowed in the domain?
Yes.
Is 2.5 greater than 2?
Yes.
This graph does not show that. This graph does. So the purpose, check it out please, the purpose of having an open circle on these the inequalities on a number line is to show that everything all the way right up to the number 2, except not 2 itself, is included. That same concept in a linear inequality graph, you change a solid, instead of a solid circle changing to an open circle, you change a solid line into a dotted line. So you were close. You don't erase the line, you just make it a dotted line.
That sounded cool.
So now I have the graph of y is greater than 1/3 x minus 2. Not too shabby, huh?
If it's less than, is it like under?
So if y is less than something, then you would be shading under. Because on the y-axis, less than is down.
Okay, and I forgot what I was gonna say.
Me too.
Mm,
All right. Now let's do 2 example problems. That's going to take this idea, and we're going to do it twice.
Can we do them on the boards?
Hold on. I want to show it up here first.
magenta plumberry.
Plumberry.
Magenta.
Red.
Magenta
White.
plumberry.
Actually, I'm going to do the green.
White. Those clash.
Better color contrast.
Yeah.
But they clash.
All right. Let's say. All right. Let's do this.
Let's.
Let's do this. 5 x, y.
Your X is on the wrong side. In respect for Abby, your X is on the wrong side.
Okay. Let's say we have. So we'll do this one first. Let's say we have y is less than 1/2 x plus 2.
I remember my question.
And y is greater than where is it? Negative x minus 3.
Wait.
Yes?
Do the graphs have to be like extremely accurate, or is it just like a rough sketch?
I'd say at least rough, slightly more accurate than a rough sketch is fine. It doesn't have to be extremely accurate.
Okay.
All right. Okay, so what we're going to, and let's say we want to graph this system of inequalities. We have to consider both of these. And we already have somebody punching on the calculator. Excellent. Keep going, and we'll see if our answers match. Okay. So what we want to do here is we need to graph each of these inequalities as if it were an equation. All right. So y is less than 1/2 x plus 2. If I pretend that that's a line for the sake of getting my line on there, that would have a y-intercept of 2 and a slope of 1/2. So then, so about here. And by the way, so I would draw my line there. Now, can it be equal to the line?
No.
No. So we need to dot this line. Now, are we shading above or below that line?
Below.
It's
Below,
less
because
than.
because y, our vertical, is less than, so that means under. And so when we have a system here, here's what I like to do. You don't have to do this, but it really helps to keep track of things. I like to put little arrows to show me what it is that whatever I shade as my final answer needs to be under this line. Okay. Now let's do the other line.
And I have another question when you're done.
Okay. Y negative x minus 3. So we have a y-intercept of negative 3 and a slope of negative 1. So it's about like this. And can it be? Is the line included?
Yes.
Yes, because y could be equal to negative x minus 3. And am I shading above or below the green line? Above, because I'm talking about greater than. So I'm going to put some up arrows here.
Do you want us to use different colors when we're doing something there?
If it helps you, then sure. You don't have to, but if it helps you, that's a great idea. That's why I use multiple colors on board. So now my final answer. So now I need to know. Well, let's take a look at what we have here. We have on our coordinate plane, our x, y coordinate plane, we have 2 lines that intersect each other, and we've divided this whole plane into 4 sections, right? There's this section, this section, this section, and this section. what section or sections do I need to shade that meet all the criteria? I need to shade everywhere that is under this line and above this line.
So it'd be like
Everyone except that left one.
Yeah. So whatever piece of the graph has arrows from both lines pointing to it is where I shade. This section right here is under the purple and above the green. So I'm going to shade this section here.
I did it.
yeah.
I used the same colors too.
Okay. And one thing that's really nice about the color editions of these things is when it does the graphing, it does it in different colors. And so what you, okay, yeah, you did the same colors. Is that focused?
No.
Can we get it to focus, do you think?
Not really.
Not really?
Touch the screen.
Well, if you touch the screen, it's going to take a picture.
Nah, not really.
All right.
They can see like a vague
Okay,
outline.
so the 284 colors look like it. You want to pass it around? And what I did just before you guys came into class here is on my HP prime calculator. Let's focus up on go up to the TV screen. Okay. So I've got these first two inequalities are the ones that I just did on the board. Y is less than 1/2 x plus 2, and then y is greater than or equal to negative x plus 3. And since this calculator can also graph things in color, when I hit the plot button, it shows me this right here. And so it had one of them as with the color above this line here, so is this section over here, and below this line is down here. And so where the darker shade is where the two colors intersect, and so this is the section that we're looking to shade on our inch of paper. By the way, I am not saying that you do this on the calculator. That's a great way to check it, but I expect you to do it manually to know how to, because you need to know how to do it.
So we don't shade the
Because
other
what?
So we're not even like we're not shading the other
You'll only shade the area that fits both of those criteria.
Okay.
One of the other things about the technology here, technology is great. You can do all kinds of cool things with it. One thing that is not clear from the technology here, at least I don't think it is. Actually, this one kind of looks like it does. It's hard to tell. At least it's hard to tell with the technology, or it might be impossible to tell from the graph that a calculator will give you as to whether a line is solid or dotted. So that's one of the things that you need to know. What I just graphed was example 91.1. 91.2. Let's see, let's check those two. These are the two inequalities from 91.2. If I show the graph of those, it looks like this. I'll leave this up on the screen while I do it manually. Let's graph these. Y is greater than x minus 2. So that's here, slope of 1. So there's this line. And solid or dotted?
Solid. No, it's dotted.
So what's the consensus? Solid or dotted?
Dotted.
Dotted, because it's not equal to. A dotted line is kind of like an open circle or an open dot. So it's dotted line, and am I going to shade above or below this line?
It's greater than, so above.
So here's y greater than, so I'm going to shade above this line. So I'm going to put some arrows here to remind me. All right, this one here, y-intercept of 1, slope of 1. And so it's going to be about like this. Not the best drawing I've had, but there we go. And is this line included?
Yes, because it's
Okay,
less
so
than
solid or dotted?
Solid.
Solid. All right, now, above or below this line? Below. Because y less than. So I need to do everything that's under this line.
Ooh, this strip.
Now it so happens that these two lines are parallel. So in this case over here, where we had two lines that intersected, and it divided our entire graph into 4 sections. In this case, the two lines are parallel, so it only divides into 3 sections. Down here, in here, and up here. So down here, in the middle, or up here, what section or what region meets both of these criteria? Right in the middle. So we have to be below the blue line and above the red line. Well, that's this whole thing in the middle. And that's why on this thing here, it does this light green, everything that's above
It looks
this
like
lower
blue.
line, and it does in like a yellowish color, everything is below this line. And so where those two cross, those two shaded regions intersect, is in this strip in the middle, and that's why this one's darker. And that's what our graph looks like here.